Hi all, this is Hani. Welcome back to our channel Code with Hani. Today we are going to solve September day 18 LeetCode challenge, which is design task manager. So then we have to design a task manager system that allows user to manage the task is associated with the priority. Okay, the system should efficiently handle adding, modifying, executing, and removing those tasks. Got it. So we have to implement this task manager class, which have the initialize method add, edit, remove, and execute top priority task. Got it. So this initialize method will have a list of tasks with user ID, task ID, and priority, which adds a task to the specified user with a given priority. So add is nothing but we are going to add a task to the list. Got it. So edit is nothing but we are going to edit the task ID's new priority. Okay, the priority got changed, so we have to edit that. Got it. So updates the priority. It is guaranteed that task ID exists in the system, so you don't need to check whether the task is present or not. Got it. So remove is nothing but that is removed from the system. That is also guaranteed task ID exists. So execute top. It's executing the task with the highest priority. So among the all the given task, what has the most priority, that task will execute. So when the task is executing, that user ID you have to return. So this is all we have to implement. So this is the exact different version of the question which we have solved yesterday. If you haven't solved that question, I will highly recommend you guys to solve that, so that it will give you a basic idea how why we have to use priority queue. So because here we have to execute the top highest priority, right? So with a list of all the tasks, instead of scanning through all the tasks, we will be using a priority queue, so which will always give you at order of one, right? Whatever the top priority exists. Yeah, like that. So basically we are, since we wanted to execute the highest priority task, so we will be for sure will be using a priority queue, and we have to return task ID which is going to execute on the corresponding user ID, right? So for that we will be using a map. So these are the two things that we are going to use to solve this question, and additional logic how we are going to add edit, that is a normal hash map things. So yeah, just take a look at the example and how we are going to solve this question. Yeah, this is the example that we have taken to solve explain the approach. So here we have four functions. One is add, edit, so 3 is remove, and 4 is execute top, right? So in this 4, so what so basically this will add to the list. Okay, edit is nothing but you will be getting the task ID and the new priority, so you have to update the new priority. So remove is you have to remove the particular task itself. Got it. So for this also you will get a task ID. So execute top only you have to return the user ID. So basically what we are going to do, so execute top will execute top priority task irrespective of the any user or any task. So we have to maintain a heap which has a top priority. So why we are maintaining heap, so that we can return the top priority task at order of 1 or order of log n to the max. Okay, so yeah, so basically what we are doing, so add but so in this among all these functions we got to know only we need a task ID as a main thing. So we will be going to maintain a task map which will have a priority and the user ID which is going to execute the task. Got it. So the corresponding, so this priority is so important to execute our task. So this is a normal task map. So whenever you are adding any task to the list, so what we will be doing, you will be updating the task map. Okay, here you will be adding it to the task map and the global heap. So the global heap, what it will do, so irrespective of the any task or something, you just need a priority, right? So that will have a priority and which task is executing. Okay, so this is what the global heap will have, so this is what the task map will have. So these are the two maps that we are going to uh, have. One is global heap and one is task map. The global heap is to execute the top. So whenever we are adding, so what we will be doing, we will be adding the task to the task map and we'll be updating the global heap basically. So here if you see, so initialization, you will have the task map and global heap. So every task, user ID, task ID and priority, which will call the add. Basically this add, and instead of rewriting the same code again and again, you can straight away call this add. This add will be basically does the same, right? So now what all the tasks we had there. So this is how the task map will look like. Okay, so the basically what we are doing, task ID and priority and user ID, like this we are adding, so that if we want to edit the particular task ID, we can get the priority, old priority, and we can update with the new priority. Got it? So yeah, so that for that edit we need the task IDs, right? So obviously we need a task ID as a key so that we can do that edit operation at order of 1. Got it? So now the will give you the task ID as a 104. So instead of scanning through all the task and you have to figure out which task ID and the corresponding you have to map. So now this is a key, right? The task ID. So 104 if comes, and if you update the, for example, now update edit it to 58. So we will be editing that as a 58, and so the same. Now the global heap will consist of whenever you are adding any task. Okay, what we will be doing, heap is nothing but whatever the maximum. Here we have to execute the highest priority task. So we have to maintain a max heap. So max heap is in Python is nothing but you have to store it in the negative value, so that in Python we don't have a max heap, right? So we will store the values in a negative so that it will, whatever the popping out will be the minimum. But if you convert again to the, if you convert the sign again to a negative, that will be the maximum value, right? So what we will be doing, so basically the global heap will store the priority. So based on this only the heap should store and the corresponding task ID. So from this task ID, okay, now we will get the user ID. So we have to return this user. So the by this two we can do all the functions. Got it? So the global heap, what it will do initially for this 5 items, the global heap will look like. So this is how the global heap will look like. So why we are doing this of task ID as well. So to take when we have the similar task priority, you have to take the ID which is greater. Okay, so since it's a max heap, we are putting a negative sign so that whatever the highest will be popping out at order of 1. Got it? So yeah, so this is how these are this is why we need the task map and global heap. So when if you take a look at the code, so basically on the initialization we will be storing all the task in the task map and the global heap. Got it? So when the new task getting added, also if they call add function, that will be getting added. Okay, so edit. Now let's see. Now as per the given example, so now if you call execute top, okay, for the first time, now if you see here global heap exists, correct? So now if we'll be taking the priority and the task ID, which is -46 and -105, so it will check the corresponding task map. Also the 105 also consists of the same priority. Why we are checking that means, so whenever we are editing the new priority, we are not removing the stale entries. So for example, if by any chance, if for now 46 was there, right? So now if you execute the top, it will execute 105 as a task. Okay, now it will return you the user ID as a 5. That is your answer here. But if now if we would have edited, now if we are editing, okay, we are editing our 102 to 58. Okay, now you, when you are editing, you will be, if that is in task map, you are editing 102 by 58 comma 2. Okay, now if you are pushing the new priority only to the heap. Okay, new priority is nothing but minus 58 comma 102. So old also exists, new also exists. Once we have updated by edit function, we updated this priority earlier to 58 comma 102. Now again by edit function, we have updated the 102 task with a new priority as a 25. So but still the stale entry exists, so now it should not execute this. So how, because it's a stale entry, how will you remove? So by checking this. Okay, from the global heap, top has 58. So 58 and 102. So 102 exists in the self task, and the priority, if equals, only we should return the user ID, but it's not equal. So what it will do? Now we have popped it out, right? 58 comma 102 is a stale entry, so we have popped it. Okay, now next one is minus 46 comma 105. So we have the 46 and 105, which is same. Now what we will be doing, since we are taking this, executing that task, we will be removing that from, we are calling the remove function to remove this from the task map. So now it will get removed here, and it got already popped out from the heap. Okay, so and we will be just returning the whatever the user ID. So what does the user ID is 5, so it will return you 5. So that's why to pop the state, so whenever we are editing, we are not editing the, removing the old priority from the heap, because we have to traverse and we have to check whether that what is the priority, and we have to remove from the global heap, right? So that will do, it will take order of n to traverse through everything, and we have to remove. So by this we can just remove at order of 1. Whenever you are traversing to the max, it can go order of log n. To log n means k, let's assume we have a k stale entry, so that we have to remove that k to the max. One time the stale entry get popped out, so any stale entry, if it got entered into the global heap, it will be popped out at inserted at insert once, and it will get popped out once. So yeah, more the stale entry only, we are checking the exact priority will be present in the task map, because we are basically updating the task map because it's a order of 1. So when you are traversing through the heap, we are removing the stale entries, and if that matches, whichever the task map matches at in the global heap on top, that is the highest priority at any point of time. Okay, so the corresponding user ID we are removing from that. I hope this is clear to you guys. So the time complexity, so add, we are doing add, right? So add is, this will done order of 1, and push will take order of log n. So log n will be the add operation, and edit will be doing the same log n order of 1 for task map and for push. So here for sure there will be a task exist for the, for which you are going to update the new priority. So remove also same, the task will be exist. Remove is nothing but order of 1. So execute top to the max, it will remove the stale entries, which will take k login. Got it? So these are the time complexities for each of the function. We can assume that total time complexity will be order of k log n. Sometimes k also might be ignored, so we can take time complexity is the order of log n. So space complexity will be order of n to store task as well as the global heap. Yeah, that's it. I think I have given enough explanation and I hope you guys would have understood. If something was unclear, please do leave a comment in the comment section. I'll be glad to assist. The GitHub link to the solution will be provided in the video description for your reference. If you found this video helpful, I would truly appreciate it if you could like, subscribe and share it with your friends. Hit the bell icon so that you will get notified daily whenever I'm posting new videos. So yeah, your support motivates me to do more videos daily. Thanks for watching.